So it's a little bit about how we at PL are keeping our gateways healthy. So why do we even need gateways? I mean, our friends from Pinata, from Cloudflare already talked a little bit about this, right? But I mean, we're all decentralized. Web3 is here, isn't it? At least all of us here who know that peer-to-peer is a thing, Web3 is a thing. So why would we even need a gateway, right? Yeah, let's just have everyone run their own Kubo node. I mean, why not, right? Those are nice thoughts, but we do have a problem. And as William Gibson once said, the future is already here. We're living in it, but not everyone is yet. So it's just not evenly distributed yet. At some point it might be, but not yet. So basically, yeah, we need gateways for all that. So let's change this a little bit, and let's call this bridging the webs. We're bridging the gateway is there because most of the people are still living in Web 2, even though we are living in Web 3, but something needs to bridge between them. And the gateway is our current chosen medium for doing that. So now, you might be asking, so who's this guy? Why is he talking to me? Why can't I just be out there getting coffee or doing something more fun than listening to this guy? Well, my name is Mario. I'm working for PL. I'm on Phil's. You can find me on Phil's Slack. You can find me on Twitter. You can find me, well, if you search for me, you can probably find me anywhere. I've been working at PL for almost a year. I started in December of last week. And I'm currently part of the Bifrost team, or Beef Roast, if you like. We are basically the gatekeeper, the keepers of the gateways. We are the guys who actually try to keep them healthy, try to keep them working, and try to keep them from keeling over, not always successfully. We also the keepers of the preload nodes, the bootstrap nodes, some clusters, almost everything that is not Filecoin related, basically. That's us. We are now 5 people in the team, up from about a month ago to now. Up to about a month ago, we were 2 people, so it's getting better. Now, before that, so how did I wind up here? Well, before that, I was actually SRE at a PLN, at a company that's part of a PLN, which is Actix. We were doing industrial systems written on top of IPFS, using IPFS as a transport layer. A lot of fun there. Now, let's talk a little bit about how things were when I joined a year ago. And a year ago, and a little bit more than a year ago, probably, a year and a half ago, something like that, the going philosophy was kind of what I mentioned at the beginning. We're all distributed, so why do we even need infrastructure? It was kind of, the gateways were a little bit of a, necessary evil. So we could actually see the problems, right? I mean, we were dealing with about 500 million requests per week, which, if you compare it to Web 2, is, sorry, I keep moving, and yeah. So 500 million requests per week, yeah, that's, not really a huge amount by Web 2 standards, but we were having a time to first byte of about 25 seconds, which is definitely not acceptable. Things were bad. So what do things look like now? And some of you might have been in Molly's talk at the beginning or in Molly's other talks, and she's been harping about every single week in the sitreps, in the Nginx sitreps, she talks about our time to first byte and the number of requests. We've gotten down to 5 seconds while dealing with 4 times the number of requests. So things are getting better. Well, not there yet. We're not at Web 2 levels yet. We might never be, just because the DHT is the DHT and distributed systems are hard. But, things are getting better. Now, how have we gotten to this point? What do we do? Well, one thing is, this is just the way we are doing it. This is the public gateway at IPFS.io and dweb.link. So you've heard people from Pinata, people from Cloudflare talk about some of the things that they're doing. This is the way we are doing it. It's not the only way to do it, and as evidenced by a whole bunch of other people that are running gateways. This is, you'll probably get the link from the presentation, but in GitHub, you look at the public gateway tester, and anybody can go in there, register their gateway, and it will tell you things like, is this gateway doing CORS or not? Is it doing IPNS or not, or something like that. So, but we're not the only ones running gateways. I think right now we're the busiest one, or at least the most famous one, because everybody uses IPFS.io or dweb.link. But still, we're not the only ones, and again, this is what we are doing. Now, what have we done? I'm going to go deeper into this, but yeah, first of all, well, people have been solving Web 2 problems for a long time. Well, let's take some of the learnings that they have had, standard CDN practices, right? There are some interesting IPFS considerations that go into how things are configured. Sorry about that. There we go. The thumbnail was too small, so that's why I kept doing this, because I could not read my own screen. So, also what metrics we are gathering, some things that we need to watch out for. So, first of all, what do we call separation of concerns? Well, the first thing that we are doing is separating the Web 2 part from the Web 3 part. And the first thing that you could think about, well, you want to do a gateway, well, why not just start up a Kubo node, expose port 8080 to the internet, and you're done, right? Have you ever tried to do that? Has your Kubo node survived? You probably don't want to do that. That is, what could happen, right? Well, as a matter of fact, multiple bad things can happen. First thing is, well, you don't want access to the API, right? API v0 add is probably the least of your problems if you're doing this. So you don't want to expose everything. There are some things you want to expose. You want to, for example, be able to gather metrics. So you do want to be able to get the API port, but you just don't want to expose it to everybody else. There is also what Matt from Pinata talked about, right? There's all this content blocking that you have to do, legal stuff, security stuff, things like phishing, things like malware. And there's also the fact that, well, Kubo, you can scale it vertically. If you give it memory, it will happily grab all the memory that you can give it until it crashes, until it actually ooms. So, yeah. You can also have Go routine leaks. That's gotten a lot better with Kubo 0.16. But the previous versions, yeah, not so much. It would basically go, it would start up using up Go routines, using up Go routines, using up Go routines, until you actually went in and restarted the thing because it got completely blocked. So there are some things that prevent you from wanting to expose Kubo. Plus, you want to scale horizontally. You want to have multiple Kubo nodes, so you need to have something in front of it, which, of course, in Web 2 terms is called a load balancer. Now, load balancing. So what are we doing here? Well, we have a load balancer layer on top. And then at the bottom, we have the Kubo layer that also has Nginx on it. And we'll get into a little bit deeper into how this works in a moment. Right? So we have, we have multiple load balancers for failover in case one of them falls and the other one will take over, blah, 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 blah. Again, normal Web 2 stuff. If you have ever done this in Web 2, this should be old hat. Now, so the load balancer is doing multiple things. It's doing SSL termination. Normally, you don't want Kubo to do your SSL termination because inefficient and better service and so on and so forth. So you want that. Of course, HTTP load balancing. You want to do retries, things like if one of the downstream nodes falls over, one of the Kubo nodes falls over, well, you want to retry to the other one or to the other one of the others. You wanted to do redirects at least from HTTP to HTTPS, for example, things like that. Some rate limiting, like what our friends at Cloudflare are doing. And one interesting thing that we're doing here is we are not using DNS for geographical balancing. So we actually have 6 points of presence, 2 in the US, 2 in Europe, 2 in Asia. Instead of using DNS for load balancing, for redirecting the traffic, we're actually terminating BGP in all of these nodes. That means that we have a single IP address. All nodes share that same IP address. And then internet routing protocols. The internet is a wonderful thing. And internet routing protocols take care of delivering your packets to the closest node, network-wise. What the big advantage that we get, at least that I've seen when maintaining this by using BGP, is that if you need to take a node offline, you don't have to, update DNS and then wait for the DNS cache to propagate and hope that none of the clients, that all of your clients are actually respecting the TTL, the time to live. You just take down the BGP daemon. We're using Bird. You take down the BGP daemon, and that node disappears from the network, disappears from the public network, and then nobody's balancing to it, and then everything is fine, everything is wonderful. Now, so that's one of the things we're doing at the Nginx level. We're terminating BGP, well, and in the Nginx nodes and the load balancing nodes. Of course, terminating SSL, they all share a wildcard certificate. They all have a wildcard certificate, normal. One of the important things that we've seen in Web 2 is that one of the most important tools that you have for getting good performance is caching. So we cache. We have our load balancers, and right now we're seeing between 15 and 25% of requests are cached, which is not bad. It's not really good, but we are not seeing too much caching because people, it turns out, are requesting different things, right? But anyway, 15, 25%, that's 15 or 25% of traffic that does not reach Kubo, which is good. And one of the nice things about IPFS is it's content addressed. It's content addressed. That means that you can cache a CID, cache an /IPFS URL or a subdomain gateway URL basically forever, because it will never change. You don't have to worry about cache coherence. You don't have to worry about, will this content be updated, so how long do I have to cache it? You cache it basically until you run out of space. That is really nice. Then, well, like we mentioned, the redirect from HTTP to HTTPS, the retrying to a different Kubo node if, for example, one of them is unresponsive for any reason. We're also doing rate limiting. We're doing rate limiting actually at both levels, both at the load balancer level and at the Kubo level. At the load balancer level, we're rate limiting per IP, and we're limiting per IP and CID. Basically, if you are on a computer and you're repeatedly requesting the same CID, something fishy is going on because you already have that CID. Why are you re-requesting it every 10 seconds? So we are not rate limiting as aggressively as we could just because people are behind NATs. So it could be that it's two different computers that are actually requesting that same content that are behind the same IP. But now if you get 100 requests for the same CID during 30 seconds, then probably something fishy is going on there. And that's basically it. That's basically our load balancer layer, our load balancing layer. Now, we then go down, and now it gets to the load balancer and goes to the Kubo node. And then we also have another Nginx that's running on the Kubo node. And the responsibilities of that Nginx is basically protect Kubo. So Kubo just listens on localhost, and we forward things via Nginx. For example, to be able to get the metrics, Nginx takes care of allowing only requests from our Prometheus instance that will get those get those metrics. And it only allows gateway requests from the load balancing nodes. Again, it's protecting Kubo. It's just so that you don't get Kubo hammered. The other thing that it's doing, we are actually using basic auth so that the load balancers are the only ones that can talk to the Kubo nodes. That's the other reason. The other thing that's not on the slide, but the other thing that we're doing, that this Kubo is doing, it's actually doing basic auth so that we don't get somebody figures out the IP address of one of the upstream nodes and starts requesting it. We were having that problem 6 months ago. So we just added, basic auth. It works so far. It's not elegant. It works. Now, the other thing that it's doing some rate limiting, again, to protect Kubo, just to not bombard Kubo with requests, just in case, I don't know, you get many requests for many long-running requests, and you're just doing you're just doing round robin between the Kubo nodes, right? So if one of them is actually, if you for some reason, because of statistics, one of the Kubo nodes is actually getting hammered, well, we also rate limit to protect it a little bit so that you don't get too many requests going on to a single Kubo node. And what will happen then is that the load balancer will retry to the other one because this one just returns 429. Now, there are some interesting considerations when you're dealing specifically with IPFS. And here's where things start getting a little bit more interesting. So far, it's just, standard Web2. The first thing we mentioned about content addressing. So aside from the fact that you can cache content address URLs essentially forever until you run out of disk space, there are a couple of other things that are interesting about IPFS. The first thing is, if a Kubo node has fetched the content, it will have it in its block store until it's garbage collected. So why should we retry if we get a request for that same CID, why should we try a different node? Why should we try a different backing node? If we know that it's already cached in the node. So we're using consistent hashing. Consistent hashing basically is an Nginx configuration that if you get a request, it will always go, that specific request will always go to one specific upstream node. Which means then that we are trying to make the best use possible of the block store, of the Kubo block store. And like we said, well, IPFS can be aggressively cached. IPNS, not so much. We actually have a configuration so that IPNS is not cached as aggressively, or actually the TTL for IPNS is a little bit less, or is less than IPFS. Now, peering. So it's important for the DHT to work correctly. You need to be judicious with your peering. One of the things that we're doing is we're peering with all the hydras. So I'm not sure how familiar you are with the Hydra nodes, but it's basically therefore making the DHT faster. So they are sharing the same. They are sharing a what's the correct name of it? They are sharing the provider record store, but they have multiple CIDs. It's a node that has a single provider, but it has multiple CIDs, which means that it reduces the number of hops that you have to go through the DHT to find a specific piece of content. If what I'm saying does not make much sense and you are interested in that, you might want to look in IPFS.io to see how the DHT works. But it's basically a way of reducing the number of hops you have to go through to get to a particular piece of content. We're also peering each gateway node with each other. Right now, since we introduced consistent caching, that is probably not a good idea or not necessary. But we're also peering with a few judiciously chosen service providers, such as Pinata, such as Cloudflare, and we're also peering with our Bootstrap nodes, etc. What else? Now, the file system. So we have been experimenting with file systems because Kubo is, not only Kubo, but also Nginx. It's I/O intensive. The cache and the block store are quite I/O intensive. You also need quite a bit of I/O. You are usually on spinning disks just because of capacity and cost. So how do you make the best use of them? So we have experimented. We actually started with extended 4. We were having some performance problems. We tried ButterFS. ButterFS, we didn't get the increase in performance that we really wanted, so now we're experimenting with ZFS. ZFS so far is nice. So the good thing about ZFS is that it gives you a lot of places you can tweak, a lot of things you can tweak, whereas ButterFS does not. The bad thing about ZFS is that it gives you a lot of things that you can tweak. So you have to experiment quite a bit to get an optimal configuration. One thing we tried was using an SSD cache. That was not a good thing because we had so much cache churn that the cache actually made things slower. And again, it will be different depending on your workload. So the best way of figuring out what works for you and what doesn't is benchmark, benchmark, and benchmark. But again, for us, with how busy the gateways are, SSD caching was not a good idea. Now, aside from that, we are doing horizontal scaling. So another one of the reasons that the gateways are now so much faster is that we went from 15 Kubo nodes at the beginning of the year to 120 Kubo nodes today. So, yeah, adding hardware usually helps. We have been scaling. Now, we originally were evenly distributed between the 6 points of presence. Now we're basically scaling them up as they start falling over. So, yes, they start falling over because you get increasing traffic, increasing traffic, increasing traffic. So we actually start scaling them up when they start falling over there. What sort of things are we tracking? So our most important metric, time to first byte. Time to first byte, P95 usually. We use a histogram. Histograms are better than averages. They just give you a lot more information. So we check our P95 TTFB is kind of our mantra, our most important metric. We also track HTTP codes. So how many requests are, for example, we alert whenever we get an excessive number of 500s, because it might be or 5xx's. It might be a bug in some of our Lua code that we're using to, for example, lop off. We'll get into. Oh, yeah, I put it in the slide and I completely forgot to mention it. Yeah, remember consistent caching? So one thing we're doing is we're lopping off the beginning of the URL just because it's always constant. /IPFS/BAFY, blah, 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 blah. /IPFS/QM, blah, 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 blah. Well, we're lopping up that up to get better caching performance, but that is done in Lua code inside Nginx. We're also converting all the CIDs we're calling into Kubo to convert all CIDs to the same format, so that even if we get a request for two CIDs that look different, but they're actually the same CID, because one of them is CID v0, the other one is CID v1, we're actually converting them to the same. And we have had bugs because, software has bugs, oddly enough. So we have had bugs there that result in 500s. So whenever we get we start getting a lot of 500s, then we have to go look into that. We're also having 410s. 410s are things that is the HTTP code that we use for content that's blocked. So are we getting a lot of blocked content? We get also how much content is rate limited, which is 429. And one discussion that we are still having at this point is, what does uptime mean? Especially in a network such as the IPFS network, because the fact that you suddenly get some requests that take 5 minutes to resolve, or 10 minutes to resolve, or never resolve, doesn't mean that your service is down. It might be that it's someone that is hosting the content on a Raspberry Pi at the slow end of a 33.6K modem. And they're trying to get that CID. Well, guess what? It will take forever, or it will never get there. So we're still having that discussion. It's one of the difficult things to define exactly what do we mean by service down? What do we mean by uptime? What metrics are useful for us? And again, this is still an ongoing discussion between Bifrost. Okay, so some things to watch out for. First thing, limits. So especially for Kubo. So one thing we're doing is via systemd, or in the case of the preloads and the bootstrappers, Docker, limit Kubo's memory usage and have the system kill it before the system actually dies. We have had cases, we have been tuning that, because we did tune that sometime this year, because the nodes were basically going out of memory and becoming completely unresponsive, which makes no sense, which is not useful. It's better if you actually have the system kill the offending process before it actually becomes completely unresponsive. So we have had to tune the memory limits to the Kubo memory limits. The Thing is, you have to be careful because you have to set them low enough so that the system will have time to react, but high enough so that you're making the best use of your memory. Right now, if I remember correctly, we're at 75%. We're giving Kubo 75% of our RAM, if I remember correctly. Same thing with GC, same thing with disk space. You don't want your block store to become full. So what do? You use GC, you enable GC, and you set a GC percentage. You have to set it high enough so that you're making good use of your space, but low enough so that it will have time to react. It will have time to actually go in and have GC. We have had cases where the GC percentage was a bit too high or a lot too high, and we get a bunch of large requests coming in, burst of large requests coming in, one after the other, and basically the file system fills up completely, and then you have to SSH in there and run IPFS repo GC. Or just go in there and use the other form of GC, which is RM minus RF, to actually clean things up because Kubo was not able to do the GC quickly enough. And they were around 70%, if I remember correctly, for the GC percentage. That's the thing about having all infrastructure in code. Since it's in code, it's not in cache. So that's why I'm saying about, if I remember correctly. Some more stuff to watch out for. Like our friend Sarpinata mentioned, people will abuse a system. So yes, this is a free CDN. It's a free, open, public CDN. What's there not to like? So people will make use of that CDN. The CDN will be abused. Now you need to set up, what do you consider abuse? Is a website using your CDN or using your IPFS nodes to host some videos because they don't want to pay Amazon to do it? Is that abuse or not? In our case, it's not. In our case, we're defining abuse by basically requesting the same content over and over again, requesting more than X number of, making more than X number of requests per second. I really don't remember the number right now. It's fairly high. It's actually fairly high. So yeah, we're rate limiting. We're rate limiting just because we want people to make a reasonable use of a shared resource. The other thing is what we were mentioning earlier in the Pinata talk about bad bits. We call it bad bits. Bad bits is basically our content blocking. Yes, we're supposed to be completely open. Yes, the internet is supposed to be free. Information wants to be free. The problem is that governments don't agree. So we have the GDPR in Europe. We have the DMCA. We have takedown requests because of malware, phishing, so on and so forth. So we actually have an email, abuse@ipfs.io, and those emails, on the one hand, it will automatically scan for any CIDs. There's a job that will automatically scan for any CIDs. It will create a pull request on our bad bits repo, internal bad bits repo. Now, one thing we are doing for bad bits is we have actually published our bad bits list, and you can barely see it here, but you can see it in the slides. It's badbits.dwebops.pub. It's a JSON, and I can I see it here? No, I can show it to you here. Let me just show it to you here. Yeah. Oh, come on. There we go. Yeah, so, I mean, we actually have, it's actually a JSON file. But one thing that you will notice is that the JSON file does not contain, there we go. The JSON file does not contain CIDs. So what we're actually doing is the CIDs that come in and get reported, so we don't want people to use this as a menu of interesting things that you might find on the IPFS network. Because people will do that, right? I mean, this is blocked. Oh, it must be blocked for some salacious reason. Let's go in there and get it. Because, it might be the latest Marvel movie or whatever. So what we do is we hash it. We actually hash the CID, we do double hashing, and we publish the hashes. When we get a request, we actually hash the CID that has been requested and look it up in bad bits. That means that we are not exposing the original CIDs, and then on the other hand, we can actually also block it. Come on. I hate this. There we go. Why did it go all the way to that slide? That's the next slide. You don't want to be there. You don't. Okay, forget you just saw this. Let's go back. Yeah. Well, anyway, we're almost finished there. And one thing that we have seen is that depending on the week, between 20 to 50% of requests are for content that is blocked. Some of that might be phishing campaigns. Some of that might be people downloading illegal content. Some of it might be whatever. So, yeah. Actually no, 20 and 50% between abuse, between rate limiting and bad bits. So 410s and 429s. Okay. So that's the gateway. That's what we are doing and so on and so forth. What alternatives do we have? Well, one of them, I mean, this is a little bit also trying to look at the future, but like Yogi Berra once said, it's tough to make predictions, especially when looking at the future. Making predictions about the past is wonderful. But yeah, predicting the future is a bit hard. But yeah, one thing we can do to get rid of the gateways or to make a better gateway, well, you know what, let's use IPFS. Let's do what we said at the beginning. Have everyone run their IPFS node. That is getting easier and easier. If you're running Brave, you just go into settings and tell it enable IPFS. And now you have an IPFS node running on your Brave browser. And it will automatically grab things from IPFS instead of going to the web. Yeah, that works. You can use the IPFS companion. And the IPFS companion, of course, that requires you to have an IPFS node running that you need to start up yourself, but it also will automatically redirect anything that is on the IPFS gateway. It will redirect it to your node, to your local node, which is nice. You can also, if you're a developer, incorporate JS IPFS on your browser, or whatever or the new, whenever it comes out, Pomegranate, or however it's called, the new version of IPFS in JS. There was a talk about that yesterday. IPFS in JS is getting better. For example, now with all the work on web transport, it will now support Quick. So it's getting better. There are multiple problems aside from also making it having more friction. It will also not work in non-computers, in non-laptops, in non-interactive computers, so set-top boxes. So Raspberry Pi that somebody's running there. It will not run everywhere. It will not. These solutions work as long as you have a browser in front of you, and you have a browser that supports any of this. If you're running Safari, then tough luck, unless you want to do your work manually. There's something else, and I'm just going to plug a talk that's going to happen in this same room at 2 p.m. 2 p.m. is Ansgar's talk, right? Yeah. Which is Saturn. Filecoin Saturn. So what that does, what Saturn is, it's crowdsourced CDN for Filecoin and IPFS content. The idea is that once everything is, Saturn is actually completely working, you will be able to earn Filecoin by running a node on your home that will help people actually get content from IPFS and Filecoin. And yeah, you want to see Ansgar's talk at 2 p.m. if you're interested in this. So, I hope that this was interesting.